Hi, my name is Michelle Eileen, and in this video I will show you how to analyze the data using the Spls 4. So there are two focuses in this video, which is data analyzing and drawing the conclusions on whether the dependent variables, mediators, and also independent variable have a significant effect between each other. First, in the data analysis sections, we will doing the model setups, interpretations, and also doing every steps of the analysis on the inner models and also outer models. So yeah, let's go. So first of all, you just have to click View Project and name your project. I name it LP. Next one is import the data file. Then you import the Excel that you want or the data that you have. But first of all, you have to change the model into CSV. If it's not, then you cannot import it into the SPLS. Then import, back, and then create the model. In the model type, you have to choose the PLSM and name the model. Save. And then in here, I use TU and TI as my the independent variables. So TU represent tag usage. You just have to drag it into the drawing path. And TI is tag innovative. And then FUI as my moderations or mediators variable. So it represents then tag usage innovations is my mediator variable, and then SI as my dependent variable, which represents social innovative. After that, you have to link all of them and connecting them by press Alt 1 at the same time and just draw the line like this, and then this, and the middle one. Alright, now the model is already done and we can start the calculations. So first, calculate and then PLSM algorithm. Start calculate with the default settings, and then we're going to interpret the outer models. So first up is vector loadings. That we click the outer loadings, and then all the indicators should be 0.7 or above it. But in here in SI1, the result is below 0.7, which is 0.683. But that we have to eliminate it. So edit, and then we delete the SI1. Then we check it again, then calculate PLSM algorithm, and then start calculate outer loadings. So all the indicators are already 0.7 or above 0.7, and with that the data is already good to be running. So the next step is we have to check the internal consistency, reliability, and convergence validity. So with that, we have to click on the construct reliability and validity, and there are three indicators. The first one is Cronbach alpha, RGOA, and RGOC. For the Cronbach alpha and RGOC, the indicators or the result have to be 0.7 or above, and maximum is 0.95 to avoid any redundancy. For the RHOA, it should be 0.7 or above, and the result has to be between Cronbach alpha and also composite reliability. To analyze the convergence validity, we can see from the average variance extracted, and it has to be 0.5 or above, which all of them above 0.5, which means the convergence validity is fulfilled. The next one is the discriminant validity. So there are three methods for this. The first one is HTMT. Then for no lookalike criterions, and cross-routing. HTMT is the most recommended one because it is used method to cross-check whether there are a problem in the models or maybe in the data or not that don't fit the criteria. So it has to be 0.5 or below it, and all of this is below 0.5, which is valid. And then the next one is the collinearity analysis. So we're gonna click the collinearity statistic fifth and click that. The result has to be below 5, and all of this is below 5, which means that the data is safe from the collinearity. So in here, the outer model is already done, and then we're gonna go next to the inner model. And basically, inner model, it represents the relationships between each variable. And yeah, we're gonna click the inner model matrix, and it shows the results of this, and it should be below 5, and all of them is below 5, which means there is no multicollinearity happens in this model. And then the next step is we're gonna go back to the drawing path and then calculate and bootstrapping. So for the subsample, we choose 5,000 because it become more reliable than the others, and it is more better if you input higher samples. And then for the amount of sample, we choose complete slower because it provides additional p-value outputs such as R-square, EVE, composite reliability, Cronbach alpha, and HTMT. And for the confidence interval method, we choose BCA bootstraps because that's the most stable method. And then yeah, all remain the same. And then we're going to start calculations. So the next one is we're gonna check about the Dirac effect. So we're gonna click the path coefficient here and check the p-value. So the p-value itself should be below 0.05, but there is one indicator, there is one path which is tech innovations to social innovative that has results above 0.05, which is 0.168. So it means that tech innovations towards social innovation doesn't have a significant effect, while the others, such as fintech used innovations towards social innovative, has a significant effect by 0.014, and then tech innovations towards fintech usage innovations has a significant effect with the result of 0.005, and then tech usage with fintech usage innovations has a significant effect with the result of 0.006, and tech usage towards social innovative has a significant effect with 0.031 as a result, as a p-value. And the next one is the indirect effect. Now we're gonna click to the specific indirect effect to see the indirect effects of the model. So in here we're gonna see the p-value, and the p-value should be below 0.05, but both of them don't below 0.05, which indicates that there is no mediations effect in this path. Now we're gonna check about the coefficients of the determinations. So for this, we go back to the drawing pod and then click the calculate and then PLS algorithm and then click the R square. As we can see here, the R value of fintech usage innovations is 18%, while the social innovative is 23%. This shows that the 23.3% of social innovative R-square are explained by three variables, which is fintech usage innovations, tech usage, and also tech innovations, while the others 76.7% are explained by the other variables that outside this research. So the next one is size effect, which is F square. So we have to click the F square selections and then we're gonna get this point. So basically F square shows that the R square value when I remove independent variables out of the model. So as you can see here, the F square of fintech usage innovations and also social innovative is small. Why? Because it's above 0.02 but below 0.15. So next we're gonna check about the Q square. So we go back to the edit and then calculate, then PLS predict CVP80, then just start calculations and look at the PLS predict LV summary. So basically, to assess the predictive accuracy of this PLS model, you have to look at the Q-square predict. So yeah, the result of fintech usage innovations and also social innovative, it's above 0 but below 0.25, which is it's a small predictive relevance. But it's okay because it's at least it's above 0. In brief, first, the tech innovations does not have a significant effect on social innovative. Second, the tech innovation has a significant effect on fintech usage innovations. Fourth, the tech usage has a significant effect on fintech usage innovative. Fifth, fintech usage innovations has a significant effect on social innovative. Sixth, fintech usage innovations does not mediate the relationships between the tech usage and social innovative. Seventh, fintech usage innovations does not mediate the relationship between tech innovations with the social innovations.